2009, 2019, and even 2022. The sensational star Betelgeuse should have exploded 3 times already, and it didn't, even though most scientists predicted it. But Betelgeuse is not the star we should be afraid of. IK Pegasi is a potential supernova that's 4 times closer to Earth, and it's the one that can explode. But for some reason, scientists keep quiet about it. The burst of energy released during the supernova explosion could destroy our planet's protective ozone layer and even trigger a mass extinction. So in this video, you'll find out, why did scientists mess up the date of the Betelgeuse explosion? How can the creation of a supernova affect our planet? And most importantly, which of these supernovae is more dangerous for humanity? First of all, let's figure out why Betelgeuse failed to explode. Back in 2019, scientists could clearly see the star's brightness began to dip. Charles Towns, a professor at the University of California at Berkeley, and his colleagues used a set of telescopes sensitive to a particular wavelength of a star's infrared light to measure the size of its disk. It turned out that over a span of almost 15 years, the diameter of Betelgeuse seems to have declined from 11.2 astronomical units to 9.6. To make it clearer, imagine Betelgeuse in the place of our Sun. In 1993, it would have extended out to Jupiter's orbit, but in 2009, it would have reached only Venus. Typically, if a star shrinks, it means it's preparing to become a supernova. So scientists thought it could be Betelgeuse's first death knells. The world was waiting for the promised explosion. But it turned out that a change in the star's size was just an illusion. Temperature differences in red supergiants can make their surfaces bumpy, causing the star to appear to be a different size when viewed from different angles. Another possibility is that the team was not measuring the star's surface, but a layer of dense molecular gas that might hover above it. That would mean Betelgeuse wasn't going to shrink, much less explode. 10 years later, astronomers noticed that Betelgeuse had suddenly begun to dim again. By February of 2020, the star had lost almost 2/3 of its normal luminosity. The second wave of scientists' sensational statements about the great dimming of the star began in the media. This time, they were sure it would definitely go boom, and Betelgeuse really exploded. But long before these statements, and it did not explode totally. Sometime before astronomers started noticing the dimming, telescopes captured the moment when Betelgeuse ejected a huge cloud of gas from the surface. It blew off part of the star's lower atmosphere, and Betelgeuse was covered by a dust cloud formed after the ejection. That's why it looked like the star faded. By April of 2020, the star returned to its expected level of luminosity. Betelgeuse never exploded because it didn't dim, shrink, or contract, but only fooled scientists with its strange behavior. Betelgeuse may not be ready to explode for thousands of years, but it's in our best interest that it happens as soon as possible. The complexity of calculating the date of Betelgeuse's death lies in the fact that scientists still don't have precise analytics on supernova explosions. This could lead to the possibility that an explosion of some near-Earth star would surprise humankind, and we won't have time to protect ourselves from a catastrophe that's already led to mass extinctions in the past. Recent data suggests that Betelgeuse is rapidly gaining mass and replenishing fuel. That means the star can delay the moment of explosion. 100,000 years ago, Betelgeuse literally devoured its companion star, which was 4 times smaller than Betelgeuse. After that, the star started spinning much faster, at a speed of up to 53,000 kilometers per hour. Since it gained mass, it increased in volume and was supposed to spin slower than usual, but scientists tried to explain such a strange activity too. The thing is that having absorbed the material of a smaller star, Betelgeuse rejuvenated. Consequently, its transformation into a supernova was postponed for many years. In addition, astronomers assumed that the star may crash into the wall of space dust that was formed during Betelgeuse's partial explosion in 2019. After the collision, the star will be replenished with fuel again. When scientists had these facts at hand, they calculated that Betelgeuse's explosion would take place at most 100,000 years from now, and the earliest that could happen is tomorrow. But we need this star to explode as soon as possible. If Betelgeuse's transition into supernova drags on for too long, it could explode simultaneously with IK Pegasi. This will start the countdown for life on our planet. I'm sure you haven't heard about the dying IK Pegasi as often as about the famous Betelgeuse. This star is at least 4 times closer to us than Betelgeuse, and its story is even more perplexing. Firstly, this star has actually died, and secondly, it's not alone. IK Pegasi is a binary star system consisting of 2 stars that share the same orbit. Meet IK Pegasi A, which is now entering its final stages of life, and IK Pegasi B, a white dwarf. As soon as the outer layers of Pegasi A begin to expand before it explodes, the material ejected by it will reach the orbit of Pegasi B. The white dwarf will absorb the gas emitted by its partner and thus increase its mass. This process will be repeated indefinitely. The substance on the surface of Pegasi B will be strongly compressed and heated. At some point, the temperature will be high enough for the flash to transform the substance into helium. It'll be followed by an explosion of such force that it'll destroy the A star and create a supernova. But it's still not the explosion we should be afraid of. Because then, Pegasi B will keep gaining even more mass until it reaches 1.5 times the mass of the Sun. Then, the core temperature of Pegasi B will rise rapidly, and this massive star will shake space with a powerful explosion. Scientists predict it'll explode in 1,000,000 years. But we all remember that they were wrong about the date of the Betelgeuse explosion, and the most dangerous outcome for our planet will be the simultaneous explosion of these 2 stars. At the moment of Betelgeuse's transformation into a supernova, the amount of energy released into space will be comparable to that which our Sun would release in its entire lifetime. The explosion will be so bright that it'll illuminate the entire galaxy. And now, imagine there are 2 such explosions. At first, we'll even be deprived of the night because the sky will be too bright for a long time. Then, electromagnetic radiation will reach Earth. Scientists predict this will happen in at least 4,000 years because Pegasi B, let alone Betelgeuse, are pretty far from us. But we remember that those scientists tend to miscalculate in their research. And just to give you a sense of the scale of their possible mistake, if Pegasi B were 30 light years closer to us, humanity would have faced a massive extinction, as there was 360 million years ago. There's an assumption that it was a supernova explosion that destroyed all prehistoric life of the Devonian period. This is confirmed by rocks found by archaeologists with hundreds of thousands of plant spores which seem to have been bleached by ultraviolet light. This is evidence of long-lasting ozone layer depletion, which could be caused by a supernova. The same scenario could happen to us. After all, what if the Betelgeuse explosion is so powerful that the blast wave will shift Pegasi B out of place? Then the ultraviolet radiation, X-rays, and gamma rays of Pegasi B will accelerate to high speeds. Once they reach our planet, they'll destroy Earth's ozone layer for about 100,000 years. In the first seconds after the destruction of our protective layer, power systems and satellites will fail. Then the particles from the blast will hit Earth with the force of 10 nuclear bombs dropped on Hiroshima. However, all this power will be focused on every square kilometer of Earth's surface facing Pegasi. Much of our atmosphere will be blown into space, and the side of Earth facing the explosion will be destroyed almost instantly. Things won't be much better for the other side. Since the blast wave can circle the globe at the speed of sound, it'll kill almost everything on land and in the oceans. And those who manage to survive will also have to cope with a nuclear winter. Humankind has never witnessed the explosion of two supernovae simultaneously. If this really happens, what will you do? Will you buy a ticket to the other side of the planet or just stock up on popcorn? Write in the comments.